Hi, hello everybody. Namaskar, Sat Shri Akal. I am Mallikarjun Patil and this is Patils Virtual classes. Yes, we will be winding up the trigonometry chapter by solving the last bit of the last exercise, that is 11.4, and last bit. We need to solve all the prove that and show that question answers. This is possible only if we know all the identities along with all the formulas which we require to resolve the identities. So here in the first question they gave us prove that cosec theta minus cot theta whole square is equals to 1 minus cos theta divided by 1 plus cos theta, right? So in this prove that and show that questions, what we need to do is we need to first consider its LHS and we need to prove RHS, and in some questions we can go for solving it with LHS separately and RHS separately, right? So what I will do here, I will use the corresponding the reciprocal formulas for cosec and the sine by cos and cos by sine formula for cot. So one cosec can be written as 1 by sine theta minus this can be written as cos theta by sine theta whole square, right? So now what I will do, I will take LCM here. Here also sine theta, here also sine theta, here also sine theta, right? And the numerator what we get is 1 minus cos theta whole square. Now I will write this whole square as separately for 1 minus cos theta whole square divided by, here what I will write, sine square theta, right? So in the last class in identities we already did that 1 minus cos theta whole square divided by sine square theta can be written as, first identity is sine square theta plus cos square theta is equals to 1. By using this identity what we can write, sine square theta is equals to 1 minus cos square theta. So here 1 is there, 1 is also equals to 1 square, right? I can write it as 1 square also. So what is the answer here, 1 minus cos theta whole square divided by, this is a square minus b square, a square minus b square is a plus b into a minus b, that is 1 plus cos theta into 1 minus cos theta, right? So here also 1 minus cos theta, here also 1 minus cos theta, here 2 are there, 1 I will get cancel. What is remaining, 1 minus cos theta divided by 1 plus cos theta, which is RHS, that is 1 minus cos theta by 1 plus cos theta is the required RHS value. This is how we proved the first problem. So here we need to recognize the identities where we were using the identities and where we were using some other different formulas in this question, right? We need to know all this. So and here in second question also we need to use some of the identities to resolve with the solution, right? So the question is cos A divided by 1 plus of sin A plus of 1 plus of sin A divided by cos A is equals to 2 times of secant A we need to prove. So I will take LHS is equals to, this is LHS, cos A by 1 plus sin A and 1 plus sin A by cos A. So what we can do here, I will take LCM as cos A into 1 plus sin A. Here we need to multiply cos A, here we need to multiply 1 plus sin A. Cos A into cos A, cos square A, plus here 1 plus sin A into 1 plus sin A, 1 plus sin A whole square, right? So what we can do now, cos square A as it is, plus here A plus B whole square formula I use. A plus B whole square is A square plus B square plus 2AB, that is 1 square plus sin square A plus 2 into sin A into 1, 2AB or 2 into sin A we can write directly. Divided here remaining is this as it is, cos A into 1 plus sin A as it is, right? Now here you can see here cos square A, here sin square A. Identity we have, first identity, what is that, sin square A plus cos square A is equals to 1. So addition of this sin square A plus cos square A, I will write 1 plus this one as it is plus this 2 sin A divided by cos A into 1 plus sin A. Now 1 plus 1 is 2 plus 2 sin A divided by cos A into 1 plus sin A. See here also 2, here also 2. What we can do? We can take 2 common. remaining is 1 plus sin a, remaining is 1 plus sin a divided by here cos a into 1 plus sin a as it is. Similar things we can get cancel, that is 1 plus sin a and 1 plus sin a get cancel. What is remaining? Remaining is 2 by cos a. This can be written as 2 into 1 by cos a, which is equals to 2 into 1 by cos means sec a, that is secant a, sec a, which is RHS. So this is how we can prove the second question also, and prove that question is the given. So cos a divided by 1 plus sin a plus of 1 plus sin a by cos a is equals to 2 times of sec a. We proved by using, again here also we were using the first identity, that is cos square a plus sin square a is equals to 1. 1 plus 1 is 2 plus 2 sin a, 2 common, then remaining is 1 plus sin a. 1 plus sin a, 1 plus sin a we can cancel, remaining is 1 by 2 by cos a. 2 by cos a means 2 into 1 by cos a, it is 1 by cos means secant theta, that is sec a. We can cancel it by doing this. We can prove LHS and RHS are equal. This is second question. The next one is third problem, third question. Okay, this is third question. In third question you can see they gave tan theta divided by 1 minus cot theta plus of cot theta divided by 1 minus tan theta is equals to, you need to prove is 1 plus sec theta into cosec theta, right? So what I will resolve, whenever tan and cot comes we need to go for writing it in the form of sin by cos and cos by sin. So I will take LHS. This is LHS. In LHS I will write sin theta as this, tan theta as sin theta by cos theta whole divided by this 1 minus, again this as cos theta by sin theta plus this cot theta can be written as cos theta by sin theta divided by 1 minus sin theta by cos theta, right? So what we can do here is, in the denominator we can take sin theta LCM, here cos theta, numerator as it is. This I will write sin theta by cos theta as it is divided by, here I will take LCM as sin theta minus cos theta divided by sin theta. Sin theta I took LCM here into sin theta, here this as it is, plus here also numerator as it is cos theta by sin theta as it is. Here LCM is cos theta, here into cos theta, that is cos theta minus sin theta. Then what we can write, which is equals to, see this will go up, this will go here and this will go here, it will multiply with the numerator. Here also sin theta, here also sin theta. What it will be, sin square theta, sin into sin, sin square theta divided by here cos theta into sin theta minus cos theta, here plus here cos theta will go here, it will become cos square theta divided by sin theta into cos theta minus sin theta, right? Then what we can write here is, what is LCM again? LCM is again sin theta into cos theta plus cos theta into this as it is. So what we can write here is sin square theta here what we can do is, I will take this sin theta cos theta common. Now what is remaining here, here in the bracket remaining is sin square theta by cos theta plus cos square theta by sin theta, right? I will continue here it. Okay, so here I made a slight change in this. This is sin minus cos and this is cos minus sin, right? To make this cos minus sin as sin minus cos, what we can write? We can make this symbol plus as minus. Then we can write this as this cos minus sin can be written as sin minus cos, so that I can take sin minus cos common, right? Now here this side as it is, which is equals to 1 divided by sin theta minus cos theta as it is. Inside the bracket, what is it there? Sin and cos, we can take LCM sin theta into cos theta. Here we need to multiple sin, here we need to multiple cos. It will become sin cube minus cos cube. It will become sin cube theta minus cos cube theta is equals to 1 by sin theta minus cos theta into a cube minus b cube. It is in the form of a cube minus b cube. Then it will be this as it is. Then this will be sin theta minus cos theta into sin square theta plus cos square theta plus sin theta cos theta. I will write once again that, don't worry. Here sin minus cos and sin minus cos is cancelled. So what is remaining? Remaining is, see, sin square plus cos square is 1. 1 plus this one is sin theta cos theta whole divided by this as it is. This sin theta cos theta. See, always I have seen many students who will be cancelling sin theta and cos theta, sin theta and cos theta here in this step only. But actually in this step, you please don't cancel the things. So you write separately 1 divided by sin theta into cos theta plus sin theta cos theta. Please don't cancel there only. You write this step so that it will help you. Many of you will cancel sin cos here. You will write answer as 1. That is wrong. Like this you need to do, and here you need to cancel both the things. See, after cancelling, what is remaining? This is remaining, right? So what he can write here? So 1 by 1, this is 1. I will write that 1 plus 1 by sin is cosec, 1 by cos is sec. So 1 by sin is cosec and 1 by cos is sec theta into cosec theta. Why I am writing like this? Because this is RHS, right? So this is somewhat difficult steps will be started from in the trigonometry only in this particular problems, and I will explain once again. The first difficulty which you may face is changing the symbol. Why this plus is changed into minus? This first thing even in your mind that question should come, right? The reason behind this is, here I took sin minus cos common. Here there is no sin minus cos. Here it is cos minus sin, right? So to make this cos minus sin as cos sin minus cos, I need to interchange the terms so that this plus will become minus. Is first important thing. Second important thing is sin cube minus cos cube formula. It is like a cube minus b cube, right? That is sin minus cos into sin square cos square plus sin cos, right? Then I took sin theta minus cos theta, sin theta minus cos theta cancel. Remaining is 1 plus sin theta cos theta by sin theta cos theta. Don't cancel here. Split the terms. Find the value. Is it clear? Can we go for next problem? So next we'll go for fourth one. Okay, in fourth problem they gave 1 plus sec a divided by sec a is equals to sin square a divided by 1 minus cos a, right? So as this is sec and this is sin and cos, they are not interrelated. In such case we need to go for resolving this, prove that separately, that is LHS separately we need to solve, and RHS. See, this LHS I will consider 1 plus sec a divided by sec a can be written as 1 plus sec can be written as 1 by cos a divided by this sec also written as 1 by cos a. Here I will take cos a LCM in the numerator, only in the numerator. Here into cos a I need to tell multiple, here into 1. So that is cos a plus 1. This whole divided by 1 by cos a can be multiplied here. 1 by cos a, it will come to numerator, it will become cos a by 1. Am I right? So now cos a cancel. What is remaining? 1 plus cos a only. What we can do with this? Nothing. So keep it as it is. I will take now RHS. What is RHS? Sin square a divided by 1 minus cos a. From the first identity again. From the first identity, sin square can be written as 1 minus cos square a divided by this 1 minus cos a as it is. Here nothing is there. I can take 1 square or 1, both are same. Why I am taking this is in the formula. 1 a square minus b square formula. What is a square minus b square formula? It is a square minus b square is a plus b into a minus b divided by 1 minus cos a. Here you can cancel. Now you may ask why directly you are cancelling. So we can take split the terms. Here no addition and subtraction. Here multiplication is there. I'll explain here. Please do listen here. In case of a plus b by c, if it is in this form, please do write it in the form of a by c plus b by c. The answer will be different. If it is a into c by c, into, if there is a into, then you can cancel c and c directly. Answer will be a only always. Right? But in this situation, or if it is a plus c by c, don't cancel c and c. It will not get cancelled. Because the c is divisible for both a and c. If you if you divide separately a by c plus c by c, then the answer will be 1 plus a by c, not c. Clear? So please do understand such situations and go on solving. 1 plus cos a. Here you can take this as equation 1, or here you can take equation 2. Don't get confusion. This is example just I explained to make you easy and clear your doubts. Right? Only this much is solution. So I can take now from equation 1 and 2. From equation 1 and 2, what we can conclude? LHS is equals to RHS. Is it clear? So next we will go for fifth problem. Okay. The next one is cos A minus sin A plus 1 divided by cos A plus sin A minus 1 is equals to cosec A plus cot A. Now this problem make problem if it comes in the exam, because this is lengthy problem. I think I may get disturbed in this board to solve also. Okay, no problem. We will try our best to resolve this problem within this particular area available for us. So I will consider LHS. So the first step is dividing the each term by sin A. I will make that as important note. All of you please do write this. Dividing the each term, both numerator and denominator, by sin A. Why? Because here is cosec and cot. Here is only sin and cos. The simple thing is we can get cosec only if you divide this 1 by sin. 1 by sin is cosec. And only if you divide this cos A by sin A, cot A will get. Right? By using such logics, we need to divide both numerator and denominator by using sin A. Each term, that is here cos A by sin A. One term over minus sin A is there. This is also divided by sin A again. Sin A plus 1 by sin A again. Whole divided by, here also same. Cos A by sin A plus sin A by sin A minus 1 by sin A again. Clear? What result we get now? Here I will write. Cos by sin is cot A minus this sin A cancel, that is 1, plus 1 by sin A is reciprocal relation between sin and cosec, that is 1 by sin A is cosec A divided by here again cot A plus sin A cancel 1 minus cosec A. See here we can do some changes in this whatever the result we got, so that we can divide and multiply by the conjugate of the denominator. What I will do here is I will make this arrangement as cot A minus, I will write only cot A minus, this can be written as 1 minus cosec A divided by, this can be written as cot A plus 1 minus cosec A. What I did here? I just rearrange the terms. Everything remains there only. No changes in this. Right? Why I did like this is, here you see it is in the form of cot A minus same thing, cot A plus same thing. So this I need to multiply and divide. Divide and multiply by the conjugate of the denominator in a rationalization you studied. Rationalizing the denominator, we call that, right? So whatever this cot a plus 1 minus cosec a is there, no, we need to divide and multiply with this conjugate. Conjugate means cot a plus 1 minus cosec a, its conjugate is cot a minus 1 minus of cosec a. Cot a minus 1 minus cosec a, I multiplied, divided by same again, cot a minus 1 minus cosec a. And please don't cancel here only and write once again. To do some steps, we divide and multiply here. Now you see cot a minus, same thing, cot a minus, both are same only. What we can write? Its whole square, that is cot a minus 1 minus cosec a whole square, its whole square, divided by, here also same, a plus b into a minus b is a square minus b square, that is cot square a minus 1 minus cosec a whole square. Am I clear? Now what we can do here, here we need to observe one thing. Here we need to apply a minus b whole square, that is a square plus b square plus 2ab. Here 2 3 terms are there, I will write that individual. Cot square a plus, here plus cosec a is there, right? Cot square a plus 1 square is 1 plus cosec square a minus 2 cot square a minus 2 cosec square a minus, how many is over, divided by, here what we can write is cot square a minus 1 minus cosec square a, cot square a as it is, minus, this is a minus b whole square, a square plus cosec square a, b square plus, sorry, minus a square plus b square minus 2ab, 2 into 1 into cosec a square 1 square plus b square minus 2ab. Is it clearly available? Okay. So this is how we need to do. Please do go through this once again so that I can continue with the problems. There we need to write some more terms. Okay, I wrote some steps here at once so that you can solve it easily. So here same, as I told, we need to write few more terms, that is minus 2 cot a, not cot square a, minus 2 cot a minus 2 cosec a plus 2 cot a into cosec a plus 2 cot a into cosec a. After this we have this step, right? So this I wrote to explain, that's it. See here, cot square a plus 1, right? This cot square a plus 1, this cot square a plus 1, from identity what we can write, this cot square a plus 1 identity we have is cosecant square a. This cosecant square a and this one cosecant square a. How many cosec square a? 2 cosec square a, right? This plus 2 cot a cosec is 0, that I wrote here, plus 2 cot a cosec a, right? So this minus 2 cot a minus 2 cosec a I wrote as it is, whole divided by cot square a as it is minus, I multiplied this minus in here with individual terms, right? Minus into plus cosec square a minus cosec square a minus into 1 minus into this minus plus cosec a, right? To explain this I kept this as it is, right? So now I will remove, if you are clear, I will remove this. Once again I'll tell, cot square a plus 1 is cosec square a, this cosec square a plus this cosec square a, how many are there? 2 cosec square a, and this last term I am writing first 2 cot a cosec a, then I am writing this minus cot a minus cosec a at last, and in the numerator I multiplied this minus with individual terms. Clear? So that we can remove this, you will not get confused, right? So here this is over. Then what I did, here also 2 cosec a, here also 2 cosec a, right? I took 2 cosec a common, here remaining is 1 cosec a plus, here remaining is only cot a, this minus 2, here also minus 2, here also minus 2, I took minus 2 common, here is cot a is remaining, here cosec a is remaining, right? Divided by cot square minus cosec square is minus 1 from identity, this cot square minus cosec, this whole, the value of this whole is minus 1, this minus 1 as it is plus as it is 2 cosec a. Am I clear? Now you see Here also cosec A plus cot A. Here also cosec A plus cot A. I will take cosec A plus cot A common. What is remaining? What is remaining here is 2 cosec A minus 2 is remaining, divided by this cosec 2 cosec A minus 1 is minus 2, so that I can cancel 2 cosec A minus 2, 2 cosec A minus 2 cancel. What is remaining is cosec A plus cot A, or cot A plus cosec A, that is RHS. See, for such problems practicing is more important. You need to practice more to get the solution of such problems, and you have to know some basic formulas like a plus b whole square, a minus b whole square, a q minus b cube, a plus b into a minus b, a square minus b square, along with all the simplified formulas of individual identity of the trigonometry. Right, in last class we discussed that only. From one identity we will get 4 formulas, 3 identities, 3 4s are 12 formulas plus 3 identities, total 15 formulas, along with all the reciprocal relation in that. So that this, if you know those all, then only such problems you can do. Right, this is 5th problem. Can we go for 6th one now? 6th problem will solve now. Okay, so here I considered 6th and 7th, both the problems simultaneously will solve, so that it will be easy for us to complete it soon here in the same screen. So here in 6th question they gave is root of 1 plus sin A divided by 1 minus sin A is equals to sec A plus tan A to prove. I will take LHS. See, as I told here, in such situation we need to resolve the numerator and denominator by factorization. Same method I will use. Divide and multiplied by conjugate of the denominator. As I said, denominator is 1 minus sin A. Its conjugate is 1 plus sin A. So multiplied by 1 plus sin A, divided by also 1 plus sin A. Right? So this is, what is remaining now? 1 plus sin A into 1 plus sin A. 1 plus sin A whole square, divided by A plus B into A minus B, A square minus B square, 1 square minus sin square A. Direct we can write now. See, here in this situation we can use this formula, that is root of A by B can be written as root A by root B. Separately we can write. So that I will use. So that is root of 1 plus sin A whole square, divided by 1 square minus sin square is 1 minus sin square. 1 minus sin square identity, first identity formula 1 minus sin square is what? Cos square A. Right? So now what we can do here? We can cancel this. Remaining is 1 plus sin A. We can cancel this. Remaining is only sin A, cos A. See, 1 plus sin A divided by cos A. Now you divide it with separately, as I told in the beginning. 1 by cos A, sin A by cos A. 1 by cos A plus sin A by cos A. Individually I will divide. Right? So now here 1 by cos A is sec A plus sin A by cos A is tan A, which is RHS. Am I clear? Nothing much difficulties there in this problem. This is short and sweet problem. Okay, this is also same. It is also same. We can solve it easily if you know some basic identities and formulas. So here also I will take LHS. So here also sin, here also sin. I can take sin theta common. I will take sin theta common. Here remaining is 1 minus 2 sin square theta divided by, in the denominator also you see I can take cos theta common. What is remaining? 2 cos square theta minus 1. Then I will take sin. See here, simple logic. Sin theta by cos theta is tan theta. We got already result. We need to cancel these two at any cost. If we cancel these two, remaining is sin by cos. Sin by cos is tan. Tan is your LHS. Right? We need to prove, or we need to just cancel 1 minus sin square theta by 2 sin square theta minus 1. Both are same. That we need to prove now. 1 minus 2 sin square theta divided by this cos theta as it is. 2 cos square theta. 2 I will write as it is. From the first identity, what is the formula of cos square? The formula of cos square is 1 minus sin square theta minus this one as it is. Now I will write this. sin theta into 1 minus 2 sin square theta divided by cos theta. 2 into 1 2 minus into plus minus 2 into sin square theta 2 sin square theta minus 1. Here again sin theta into 1 minus 2 sin square theta divided by cos theta into 2 minus 1 is 1 minus 2 sin square theta. 1 minus 2 sin square theta 1 minus 2 sin square theta cancel. Remaining is only sin theta divided by cos theta, that is tan theta, which is RHS. Am I clear? See, it is also not much difficult. It is also easy. So this will be easy if we know the simple simplification methods along with some formulas, right? So this is about 6th and 7th. Can we go for 8th and 9th now? So okay, we will solve now 8th problem. Okay. See, here I consider 8th and 9th problems together. We need to resolve this problem by using the formula. Here is the simple formula LHS, as you all know, a plus b whole square. It will take long, so I kept the space there. It is a plus b whole square. It is also a plus b whole square. The formula a plus b whole square is a square plus b square plus 2ab plus here also a square plus b square, that a plus b whole square, that is a square plus b square plus 2ab cos a into sec a, right? So this is a square plus b square plus 2ab, a square plus b square plus 2ab. So both the formulas I took. Here what we can consider is wherever we get identities, that we need to consider. Here is sin square a, here is cos square a. Directly I am going to write sin square a plus cos square a 1. Sin square a plus cos square a is 1. So then what we can write? Cosec square a. What is the formula of cosec square a? Cosec square a is 1 plus cot square a plus here 2 sin a into cosec a can be written as 1 by sin a plus cos is over, we cancel already. Secant square formula is 1 plus tan square a plus here also 2 cos a into this sec a can be written as 1 by cos a. Now similar things you can cancel, that is cos a and cos a get cancelled, sin a and sin a get cancelled. What is remaining? 1 plus 1 is 2 plus cot square a as it is plus this 2 as it is plus this 1 as it is plus this tan square a as it is, tan square a as it is, plus here is also remaining 2. Now you just go on counting the numbers here. 2 plus 2 plus 1 plus 2 is how much? 2 plus 2 is 4 plus 1 is 5 plus 2 is 7. 7 here tan square a, here cot square a is remaining. And what is this? 7 tan square a plus cot square a is our RHS. Is that clear? Simple formulas we used, two identities we used, that is second and third identity, and a plus b whole square formula used. Clear? So here in 9th one, in 9th, as I told, both are, they are not interrelated with each other. We need to take LHS and RHS separately and we need to prove. So I am going to take this LHS cosec a minus sin a into sec a minus cos a by using the regular formulas, that is cosec can be written as 1 by sin a minus sin a. This is 1 by cos a minus cos a. Now what can take? LCM is sin a, in the numerator 1 minus sin square a. Here also same, what we can do is LCM is cos a. The remaining is 1 minus cos square a minus 1, right? So formula what is remaining, what we got formula here is 1 minus sin square a is cos square a. Cos square a by sin a into sin square a by cos a we will get. Here cos a 1 cos a, here sin a 1 sin a, cancel. क्या बच्चा? Cos a into sin a is remaining only. Here remaining is only cos a into sin a is remaining only. This is about LHS. I will take answer RHS now. 1 by tan a plus cot a, 1 by tan a can be written as sin a by cos a plus cos a by sin a. Then what we can take? 1 divided by, I will take LCM. LCM is sin a cos a. Here into sin a, here into cos a. Sin a into sin a, sin square a plus cos a into cos a, cos square a. I will take this to numerator. So it will be cos a into sin a divided by what? Sin square a plus cos square a. What is first identity? Sin square a plus cos square a is 1. 1. So what is the answer? Cos a into sin a. Here you can see both LHS and RHS are equal. You can take equation 1, equation 2 and you can write therefore LHS is equals to RHS. Such problems we did already, right? Simple logics are there, so please do apply the logics and you can resolve the problems directly. The remaining is only one problem. You will do homework that problem? Yes, always the teacher used to tell only one problem is remaining, please do homework. So here we not, there is no compromise. We are going to solve the 10th problem also, right? So now we will go to solve 10th problem. Okay, so here is the last and the 10th problem to prove that or show that. Here two things are they given, both we need to prove it as tan square is simultaneous, similarly as like we proved in the last problem. LHS RHS separate, I will take this as LHS RHS and prove both are equal to tan square a, right? So I will consider this now, that is 1 plus tan square a by 1 plus cot square a. Tan can be written as sin square a by cos square a divided by this can be written as 1 plus cos square a by sin square a. Here I will take LCM as cos square a. Such problems we did already so many now. Here into cos square a. So the numerator will become cos square a plus sin square a divided by, here it will become, I will take LCM as sin square a, it will become sin square a plus cos square a. Again first identity, sin square a plus cos square a is 1 by cos square a. Here also sin square a plus cos square a is 1 by sin square a. It will go up, it will become sin square a by cos square a, and the formula is sin by cos is tan square a. First one we prove, first one is equal to tan square we prove. I'll consider second one, same 1 minus tan by 1 plus 1 minus cot is there. So tan means what we can take is sin by cos, that is 1 minus sin a by cos a divided by 1 minus cot a or we can use a minus b whole square formula instead of doing this. It's okay to cot a by sin a. Here also whole square, here also whole square. So what I got here is cos a minus sin a whole by cos a whole square as it is divided by, here what I get, this is cos, that only I'm thinking, okay, cos. Here I get sin a minus cos a whole by sin a, right, whole square. Once again we can write or else we can just use here a minus b whole square formula instead of doing this. Next one is 1 minus tan a whole square by 1 minus cot a whole square. I will take 1 minus tan a whole square by 1 minus cot a whole square. This is like a minus b whole square. A square plus b square minus 2ab divided by a square plus b square minus 2ab. 2 cot a, sorry. 2 cot a. Right? So here we need to use identities, that is 1 plus tan square is 1 plus tan square. What is the identity of 1 plus tan square? 1 plus tan square identity is secant square a minus 2 tan a divided by here cosecant square a minus 2 cot a. Right? So what is remaining here? I can take this see secant square a can be written as 1 divided by cos square a minus 2 sin a by cos a divided by here also same 1 divided by sin square a minus 2 cos a by sin a. Right? So in the numerators the LCM is cos square a. The LCM is cos square a. That cos we will multiply here to get cos 1 minus 2 sin a cos a. Here also same. Here sin square is LCM 1 minus 2 sin a cos a. 1 minus 2 sin a cos a whole divided by 1 minus 2 sin a cos a. Can you guess why and how it is coming? Sin square a. Here 1 minus 2 sin a cos a, 1 minus 2 sin a cos a cancel, and the sin square will come here and it will become sin square a by cos square a. तो क्या आया? Tan square a. This also is equals to tan square a we proved. This is also equals to tan square a we proved. Is that clear? So this is 10th problem solution. We proved that. Prove that. We proved all the 10. Prove that and show that questions. So the probability of, as I told in the last class, the probability of coming one question, probably 99%, it may come from these all 10 problems if your luck is good. If not, they may ask some similar questions as similar as to that of these all 10 or between any one out of these 10, or direct the one question come from these 10 problems only to the annual exam. So please do prepare, read, write, practice, and do well, and follow and subscribe the Patil virtual classes. Thank you and enjoy learning mathematics.